So another way to think about the Gerken results with artificial language data with respect to Bayesian inference is about expectations, about incorporating expectations into what you see and what you don't see, right? So a child who thinks that the more general hypothesis, this AAB hypothesis where two syllables repeat and then you have a third syllable, a child who thinks that one is true will expect to see data that follow that one but are not compatible with the more specific ones of two syllables that are the same followed by the syllable D, right? So that she'll expect to see counterexamples to H1 if H2 is actually true and H1 is not true, right? And so if a child keeps not seeing those data that are counterexamples to H1, that is those that are compatible with H2, like the one like she would expect to see if H2 were true, this is evidence that H1 is in fact the right hypothesis, the lack of counterexamples. So this is an example of indirect negative evidence because this is what she's expecting to see and what she keeps not seeing. So the indirect is about expectations rather than certainty, and negative is about what's not in the input. Right, but let's focus on counterexamples a little bit more because this is again one of the nice things about Bayesian learners is that Bayesian reasoning is sensitive to counterexamples, those things that are not compatible with your current hypothesis, right? So if even one word in the intake, this is sort of an extreme example, the sort of the optimal Bayesian learner, but if even one word in the intake wasn't compatible with that more specific, that less general hypothesis, then a Bayesian learner would notice that and shift beliefs. So if you get Lele Wei and you thought this was the right hypothesis, well, Lele Wei is not compatible with that. So that's your counterexample. That says, just kidding, let me shift to this more general hypothesis, right? And we can see that when we look again at the actual implementation of Bayesian inference, in particular the likelihood of generating data points. So let's suppose that you see your four data points here that are compatible with both the more specific and the more general one, but then you get this fifth guy, right? And under this more specific hypothesis, you cannot generate that pattern. It does not follow the pattern of the more specific hypothesis. So the likelihood of generating that data point is 0, right? So your actual likelihood of generating the entire data set is 0. Compare that with our more general hypothesis where each individual one is a little less specific, but you can generate them all. So now you get a likelihood that is small, but not 0, right? So 0 versus not 0, guess which one wins? The not 0, right? So that's how you move from the more specific to the more general hypothesis based on these kinds of counterexamples, right? So again, only the more general hypothesis, H2 in this case, is going to have a non-zero posterior. So that's why the Bayesian learner is going to prefer H2. And the question that Gerken in 2010 asked was, do 9-month-olds reason this way too? Because they clearly have the bias to prefer the more specific hypothesis when you have ambiguous data. But what about counterexamples? So we have a setup that was really similar to what we saw in 2006, where you get a whole bunch of data that are compatible with the more specific hypothesis, but then at the very end, you get 3 counterexamples, ones that are only compatible with that more general hypothesis, right? So those should be the counterexamples. If you're acting like a Bayesian learner should, you should be moving to that more general hypothesis. And then the test, right? Do you actually behave the way we would expect you to if you've made that more general generalization? Do you like Cocoa Ba over Kobako, or don't you care? Right? Because if you didn't move to that more general hypothesis, you don't have a preference, right? So just to recap that, if children learn the more general pattern from these 3 counterexamples at the end, they'll prefer to listen to things that follow that more general pattern like Cocoa Ba over things that don't, like Kobako with novel syllables. This is exactly what we see. They prefer it when you get those 3 counterexamples at the end. And this contrasts with what happened when they didn't. When they just got the ambiguous data, they didn't have any preference because it seems like they stuck with that more specific hypothesis. So infants, just like we would expect Bayesian learners to, are sensitive to counterexamples.